Boy, that feels good. Really nailed that dimension. Okay, let's test fit this on the mating bushing now. And what the fuck? Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to finish up the Kant Twist clamps that we started last week. We're going to make all the rest of the parts and then we're going to clamp some stuff. And like I said last week, I have a set of these clamps as a kit that you can make yourself. Stay tuned to the end of this video to see how you can enter a contest to win these. Let's go. Picking up where I left off, I'm going to start by making the jaws here today. So the kit comes with this aluminum bar for the purpose, and I'm going to bring in my old friend the 10 flute shell mill, which I haven't shown in a while, but for a large shallow cut on aluminum, it's just the thing. This is an awful lot of cutter for this tiny little mill, but for aluminum and just light cuts, this does just fine and it'll save me some passes. So I'm going to face one side and then face a second side and then bring the other two sides down to dimension, just like squaring stock. The stock is quite a bit oversized for what it needs to be for the jaws, so there's a fair bit to mill off two of the sides, but of course I'm deburring between steps and I'm not going to go through all the details of squaring stock here. I've done lots of videos on that and I'll link to one in particular below if you're interested in the intricacies of this process. But you know, tappy tap tap for the fans. Aluminum is a lot of fun on small machines like this though, because you can use big cutters and take big cuts and spray chips just like a real milling machine. With that, I've brought the stock to dimension on the X and Y for all four clamp jaws, and so now I can cut them apart. Now if you were going to do this on the lathe, you would cut them apart first and then turn each one down to size using the Turner's cube method. There's lots of good videos on that if you're interested on how to make cube-like things on the lathe, but I'm going to cut it apart now. And to build a little character, I'll start with the hacksaw. Then I remembered that character is way overrated. Now I can bring those saw cuts down to dimension. None of the jaws are actually cubes. They're all the same dimension on two axes, but the third axis is different for each pair of jaws. So I'm going to clean up one side of the first jaw here, and I've got a piece of one of the other jaws in the other side of the vise there to keep the jaw balanced and keep a good grip. And this works because these were all squared up in the same setup. If you want to be really sure, it never hurts to put a piece of paper next to the part that you want to make sure gets the better clamping of the two. Importantly, I faced one side until it was cleaned up and then flipped the block around, and I'm bringing it down to dimension on the other side, and this will be important here in a minute. Once again, this being aluminum, we can take beefy side milling cuts and spray icicles all over the machine, which is lots of fun. Once I'm close, I'll take a measurement here and then I can do my finishing pass. So I'm bringing the first of the larger jaws down to dimension here, but I only have to measure once because then I zero the DRO once this guy's on dimension, and then I set up an end stop and bring that in, and that back side has been faced already, it's machined. Now I can remove the finished part and swap in the unfinished one, and then I can use the finished part as the buffer on the other end of the jaw, once again to keep that jaw straight, and then clamp that down. And the cool thing is, now I just have to mill down to 0 on this part on the DRO because of the end stop. It doesn't matter where the milling started, it only matters that I finish on the same 0. Then for the two narrower jaws, I did the exact same thing. I did the first one kind of cautiously and then measured it to dimension and then zeroed it and then set the end stop and milled the second one down to 0. So I only had to measure half of my little blocks. For all these operations, I'm using WD-40 as a cutting fluid, and with aluminum it's really just about keeping buildup from accumulating on the tools. Next up, I need some reamed holes through the centers of these blocks. So I'm going to center up using the edge finder on all four sides and the half functions on the DRO on both X and Y. And once again, vice stop to the rescue, because the center holes of all 4 jaws are in the same place. They're on one of those sides that's square on all 4 jaws. So now I can save lots of time by doing the same operation on each block. So I'll start by center drilling, and the vice stop repeats everything perfectly. Then I can switch to the drill them all slightly undersize, and then switch to the reamer and ream them all, and I've minimized tool changes for maximum mass production efficiency. Trouble afoot with the reamer though, I need to hold it in the Jacob's chuck because I don't have a collet that's the weird shank size on this reamer, so I had to shorten my parallels in order to get just enough clearance. However, end stop to the rescue once again. Because I have that stop on the vise, I can take the part out, change the parallels, and the end stop is going to ensure that my part still ends up in the correct place on X and Y. And now it's low enough on Z that I can sneak the reamer in there. If this had not worked, then it would have been easy enough to just set these up on the lathe, dial them in using the hole that I drilled, and then ream them. For the shorter jaws, it's even trickier because I still have to keep them at the top edge of the vise in order for the end stop to work, so I have to find taller parallels that are not too tall and still fit under the reamer. This is one of those unsung advantages of thin parallel sets, is not just that they're thin, but you get a lot more heights in the set, so you get lots and lots of different choices for vertically positioning your parts in the vise. With everything chamfered, let's do a test fit on one of these standoffs. These ride on the standoffs and spin so that they can adjust as the clamp opens and closes. And that fit is delightful. I just never get tired of things fitting beautifully. That's why I love machining. Next up is V-grooves for the jaws for holding round stuff. And I'm going to kind of cheat and use this chamfering tool. And the cool thing is the grooves go on the x-axis on one of the same dimensions as the reamed holes. So that means I don't have to adjust anything in my setup. I just rotate these little cubes and my DRO is still set with the center line already there. So these x-axis grooves are going to be easy, and the drawing specifies how deep to make them. So this was easy. I just touch off on the top and go down the right amount. Cutting V-grooves can be complicated. I've done a video on that recently in my cross-drilling fixture, but if you're just making small ones, then a two-flute chamfer tool like this makes it very, very easy. All 4 x-axis grooves were done that way. Now the y-axis ones, they need to be on a different center line. However, I don't have to edge find anything because I can just do the math from where I was on the wider part, subtract half of that from half of the narrower part, and I can get on the new center line. Because remember, the DRO isn't just tracking one edge of your part, it's tracking all points on your part. And by extension, all points on the vise, so when you put another part in there referenced to the same stop, you can now map the surface of one part to the other with a little arithmetic. And just like that, we've got both V-grooves on all 4 jaws. Pretty pleased with how those turned out. Wait a minute, how do you do those V-grooves on a lathe if you're doing this as a lathe-only project? This is how. You have a light-duty milling attachment on your tool post already in the form of a tool holder. You can clamp a part in there, and you've already got the height adjustment on here, and so you can get a center line on your lathe spindle and put the V-groove cutter in the spindle and mill yourself the V-grooves this way. Now, of course, this requires you to have tool holders that are big enough to hold the part, but you could also try to fixture them in some way to the tool holder as well. On to the lead screws now. I've got this long chunk of stock to make 2 of them out of, and I'm going to use the 4 jaw this time because I want to be able to keep all of this stock in one piece for both lead screws. I'm going to make them together because it's going to be easier to hold them for subsequent operations. So I'm going to work with the stock pulled out to full length just in case there's a slight bend in this bar. So I'm going to dial it in on the close end, and then I'll check the other end and see if it's running well. And the other end can be tapped in as needed. If there is any slight little bend in this bar, I want to know about it now, and I can drill the center with that in mind, which is why I'm doing this with the stock pulled out. The OD of this is getting turned down, but not very much, so I want to be really sure I get this part as straight as possible and compensate for any little bend that might be in it. I dialed it in at both ends as best I could, and that looks like it's running well. The stock was pretty straight, so I'm not very worried about this. I'm going to bring in my steady rest now because I do need to face the end, and I'm going to be doing some drilling and tapping so it can't hurt. These days I find it works well to just bring these in until the rollers start spinning with the stock spinning, and then I just tighten them in that position, and that seems to land me on the correct tension on the rollers every time. With everything oiled up, I can now face off the end, as is tradition. What's interesting about this part is we need a threaded hole in the end, but we also need tail support. So here's a little preview from the future of what we're aiming for. It's a threaded hole that still has a centering taper around the top edge of it. So I'll show you how I'm going to do that here. So I'm going to start by center drilling it. And basically what I'm going to do is just make a center drill that's larger than necessary for the hole that we're going to drill. So center drill that, and then I'm going to drill it tapping size. After the drilling, I realized I had guessed wrong on how big I needed to go with the center drill, so I had to come in with a larger one, which is not ideal, but it'll still end up with a pretty good center here. It'll self-center on the old one to some degree. Now we've got a taper showing there outside of the hole, and now I can go in and thread it. I'm just going to take one of the screws from the kit and double check that it bottoms out all the way, make sure my threads are deep enough. This screw is what retains the lead screw in the clamp, so it's important. Now get rid of the steady rest and bring in the tail support using that extra little taper. Now I can start turning the OD. I've got an extra narrow 55-degree tool here that I grind for just this purpose. It allows me to get into small diameters really close to the live center like this. So I'm turning down a shoulder at the end here, and this is kind of like a bearing surface. It runs inside a bushing that we made last week and is what holds the lead screw in place and allows it to spin. So this dimension's fairly important. I left it a little bit large to start because the finish that sharp angled tool leaves is not great. It's one of the issues with it. It's the price I pay for having good clearance around the back side of it. So I left it large, and I can come in here with the emery paper and clean up that finish and bring it down to dimension. I want to really nail this dimension because it is basically a bearing. Okay, I can test fit the bushing that this thing rides in. And wait a minute, that's not even close. Something seriously went wrong there, but we'll talk about that in a minute. For now, however, I'm going to get set up to put the threads on this thing. And I'm going to cut the threads with a die because, frankly, I've had my fill of single point threading lately, so I'm just shaving a few thousandths off of this to give clearance for the die. And this is a long, slow cut, so hey, you pass the time how you want, I'm going to pass it how I want. To cut this long thread without single pointing it, I'm going to start it with my tailstock die holder, and that guarantees that the thread starts straight. But my tailstock die holder can only do about 1 inch of depth, so that's not going to help us here. So then I switched to a die stock that I recently made, and this has a pass-through on the back that will allow me to cut all the way down. So I did this for a while by hand, but the problem I'm having is that it's slipping in the forejaw. I've got aluminum shim stock in there to protect the work, and it's not a very tight grip, and no matter how hard I tighten that chuck, it slips. So I'm going to have to part it off now and change my setup a little bit here. If I part it off, I can bring in the collet chuck, and this has a much, much better grip. With the collet chuck on there, it's got a very good grip now, and this is working really well, and it's cutting pretty well. So well, in fact, that I think I'm going to try something stupid. I'm going to put the handle of the die wrench on a board and run it under power. I started it back a little bit to give it a running start, and here goes. Oh, right, that moment right there is where we find out if the MOSFETs were going to burn out, and they didn't, and the lathe took it, and it's taking it. It's using both halves of its horsepower for this, but this is working surprisingly well. And yeah, it's a little terrifying. There's lots of smoke and chips are really flying out of there. You have to make sure it doesn't get caught, so I'm giving it a little help there with my hand. But that actually made a pretty nice looking thread very, very fast. So it's hard to argue with that result. Now, however, because I cut off my stock, I'm going to have a little bit of trouble when it comes to cross-drilling that hole. But that's a problem for 1 minute from now, Quinn. Current Quinn is going to face this down to final dimension there for the top part of the lead screw. Quick deburr, and now I can worry about that cross hole. So my plan was to have both lead screws still attached, and I could use the area at the top of one lead screw to hold it in a collet block to drill the cross hole in the other lead screw and vice versa. Don't have that luxury anymore, but I still have this cross drilling fixture which I used earlier, and I'm sure glad I made this thing because it's going to come in handy once again. So now I can just edge find on the end of the part there using gauge block and add that to my dimension, and that allows me to find the right position on the part. And now I'm going to ream it with a secret weapon. I have over-under reamer pairs for many common sizes. I want a nice easy sliding fit for the T-handle, and an oversized reamer is just the thing. It cuts, as the name says, a little bit oversized and gives a really beautiful sliding fit every time. So there's the drill rod stock that the handle will be made of. It moves beautifully. Okay, 2 lead screws done. Now let's look at that mismatched bore problem once again. So what happened here? How did this get so wrong? Well, I double checked the drawing and the end of the lead screw is indeed supposed to be 250, but the bushing is marked as ream to 5/16. So this is actually an error in the drawing that I didn't catch in time. And this is a prototype of the kit, so little errors like that are going to happen. I reported it to the developer and he's going to fix it. The good news is we can fix this and actually do a little upgrade. Step 1 is to figure out how big the hole actually is. Ostensibly it's 5/16 because that's what I reamed it to, but I got to make sure it didn't cut oversized because I need a very precise fit, because what I'm going to do is I'm going to make a brass bushing that goes in there. And yeah, that's actually dead nuts on, so that's nice. So I drilled and reamed a hole down some brass here to make a sliding fit on the lead screw end. I used an oversized reamer for this as well, so I've got a nice spinning clearance in there. And that's looking really good. And then I carefully turned down the OD to match that diameter that I measured. And I'm aiming for a very close sliding fit because I'm going to Loctite these in, not press them in. They're very small, delicate bushings, and pressing them in is likely to distort them. So I'm going to use Loctite instead. That, I think, is going to work perfectly. And now I can part this off, and we should be good to go. So I'll do a test fit here. Goes on the lead screw very nicely, and then that all goes inside the bushing like so. And of course that will be Loctited in and we'll have a nice little bearing. That's beautiful. Now, bronze is a slightly better bearing material than brass, but for a screw clamp, brass will be just fine. And hey, while we've got the yellow stuff out, I'm going to make some brass parts that the clamps need. So there are 4 beveled bushings that go on one of the pairs of screws. So this is a pretty straightforward part to make here. The bevel there is just decorative, so you make that to taste. And then I need to drill all the way through a longer section here to make 4 little ferrules that go on the ends of the Tommy bars for the clamps. So these are drilled through and then threaded all the way through, and then I just part off 4 of these little guys. G'day, welcome back to Blondihacks. There's all of my brass parts for these clamps. On to the Tommy bars themselves now. The kit came with this nice piece of drill rod, so very little to do here. I just faced the ends, put a little chamfer on there, and then I cut threads for the ferrules on the ends there. And for the depth of these threads, I actually just did it by trial and error. I just did a couple turns at a time until the length was just right. Thread that on there until it comes up nice and flush. And then I'll probably put some thread locker on those. I like the idea of them being threaded on so that I can take the Tommy bars out if I ever need to. Okay, we have a bucket of parts here. Let's make some clamps out of them. And that's one of the short legs, just so you can kind of see the relationships between all the major parts there. The hinge pin and the bushing and the spinning jaws there all in place. And then we put all the screws in to retain all of the clamps. And you can see how all of these parts have to be the exact same length for the plates to land parallel and for everything to work smoothly. So I assemble the lead screw with the screw in the end to retain it, and oh boy, that moves nicely. That is just, wow, that is really, really smooth. I'm very pleased with that. Let's see how I did on jaw alignment. So the V grooves there should come together, and yeah, that looks good. There's a little bit of lateral play and things, so if that hadn't been perfect, it's not the end of the world. But that clamp moves very, very smoothly. I'm impressed with how quickly you can open and close these actually. And the jaws rotate so you can pick a smooth side or a V groove as needed. To protect them, I'm spraying them with this CRC corrosion inhibitor, and then a little bit of oil on the ends of the lead screws there to go into the bushings. And I'm going to put some oil on the lead screws as well and just run those up and down. Well, they look like clamps, but are they clamps? Let's find out. Here's 2 pieces of square stock, and yeah, boy, That feels extremely solid. That'll definitely crush the skulls of my enemies as needed. Well, if my enemies have tiny, tiny heads. Let's try clamping something round into a little V block here and using the V groove on one jaw and the smooth side on the other jaw. And again, that worked extremely well. So these are very, very strong clamps. Of that, I have no doubt. And I think these will come in extremely handy in many, many setups here in the shop. And hey, when I start building my Terminator army, I've got 2 claws ready to go. And like I said, I've got an extra one of these kits that you can win. I'm running a contest on my Patreon. There's a link below or in the corner of the screen there. So head on over there to see how to enter to win this kit. It's got all the stock that you need to build these clamps, and it's got all the drawings, build notes, instructions. Really awesome kit. There's my 2 clamps. I hope you enjoyed watching me make this kit. And once again, check out the link below if you want to buy your own kit, or check out my Patreon if you want to enter the contest to win a kit. Thank you very much for watching, and if you liked this video series, then throw me a little love on Patreon maybe, and I will see you next time.